Hey, we are now back with another notional pipe stream, and today we are going to do what I thought we were going to do last time, which is to start putting together the whole system and rig an actual character with it. Now, in this case, there's a couple of things we need to do first. A few things that I left there to be done, specifically because I wanted to show some of the ways that the different components can interact together, especially around the hips. Before I do that, though, let me actually show a couple of things that I have done, in between sessions, because they were basically extensions of what we had already shown on the stream, and I didn't think just watching me go and do these things again a couple of times was necessarily going to be all that effective for people. It was not necessarily a great use of our time. So let me just go into a couple of what those things are. Number one, and this is probably something that will be real evident, is look at these nice little locators that that Tagore and Brian made for me. These basically are things that draw little spheres and connectors, and they don't actually change the behavior of the systems from what you'd seen me construct on the stream. But what they do is to make it much easier to see what you're doing. Like, we remember, as you may recall, we had like a bunch of just random, regular, normal locators, and they were hard to select and they were hard to see. And what users will generally see when using this system in context is, if we hide the components, this is what they'll see. So, very similar to, say, the setup machine, right? And I've rigged them up to, like, control their size appropriately. So if you make it real big, like, everything will work properly. And since that's relatively straightforward, though, I didn't want to take a lot of time to do that on stream. I also made a head component because we didn't have one of those before. And again, that's following the same rules that we constructed for all the other components, and isn't particularly special or notable in any way. So I figured might as well go ahead and just make one. And then finally, I did some work around the mirroring. One of the things I realized, and this is of course a very normal scenario that one gets into when one is doing things and then one tests them and one discovers that they are not quite what one originally intended, is that you discover that you need to change some things in some specific ways. And the particular way in which I needed to change this, and this is something that if you go back and watch any of the sections that we did on mirroring, you may recall that one of the primary things we had to do was to arrange it so that on this side, these guides are pointing, they're aiming down the chain, right? And they're aiming down on positive X. And then if we say, go look at the elbow on the other side, it's aiming down negative X. And so I had a side attribute that flipped this aim vector in the constraints from a 1 to a -1. What I had neglected to do, and this wasn't evident until I put the whole thing into the body plan and checked out how it was working, is I had neglected to do the same thing to the up vector. And the reason why that matters is that if you don't do that, sure, you'll still get something where they are sort of mirrored and it'll look vaguely correct, but you won't, sorry, let me switch this out of IK. What you won't get is this, which is really what you want. You won't get the mirrored rotation. Now, of course, if you want both mirrored rotation and translation, you have to actually do it under a scaled space, which is something I considered. Nothing wrong with using the componentized system in a context in which you're doing mirroring by having a scaled space. I decided not to do it for the limbs in this case, for a variety of reasons. A great deal of the reason for that actually is that, unlike, say, the Setup Machine 3, where we did in fact do everything mirrored in exactly that way, in this scenario, this is something that I'm kind of more expecting users to directly constrain their other things they might be making in their rig to it. It's a little bit more general, and the possibility for confusion, because constraints don't necessarily work correctly when you're targeting a transform under a scaled space, was, I think, high enough that I decided not to do that in this case. I thought that it was going to ultimately probably be trouble, even though it's a technique that I really like, and I would definitely still use it on a face, even if using it, in this context. But anyway, I essentially wanted to simply go and mention those things so that, since things do work slightly differently, I mean, mostly what you're seeing here is just the same stuff that you've seen me set up on stream. But because there are a couple of additions, I wanted to make sure to call those out and make it clear what the additions were. And as you can see, what I'm doing here with the up vector is, it also flips to -1, right? That is what produces the correct behavior. So let's see. We're actually at this point, there's really only one thing and that we need in order to be able to start actually, putting it inside a character and start binding it. Well, there's really two things that we need, to be perfectly honest. One of which is going to be the ability to mirror the positions of these things, the transformations, over to the other side, which is going to be a little bit of a pain, and we will have to do that today. One of the things I will say is I refrained when putting together a description of the stream this time on saying yes, we will definitely be finished, because I thought that was going to be true in the last stream, and I turned out to be completely wrong about that. So I have given up on thinking I know for sure how long things are going to take when I do them on stream. But this question of how to handle the hips is one that I think gets to the heart in some ways of the sorts of things that you can do with the componentized system and some of the advantages of the approach. So I wanted to leave those elements to do on stream for sure. And what's going on there is that these bits here, I mean, currently they work fine, right? But as anyone who has looked at any of, the rig tool sample rigs, or read the manual, or looked at a lot of the other videos or anything knows, there's this whole idea of overshoot, right? And we're doing this in lots of places, right? There's an overshoot, there's a bit of overshoot on the hand, right? This is the wrist, you're overshooting the spline into the hand to get the nice contour deformation. The same is true, basically everywhere, and it's true for the legs too, but here's how it's different. What you generally want when that happens is you want these bits here to move along with the spine. Because if they don't, and the spine bends, they are not going to shift with it, and you won't get the nice deformation in the legs anymore, around the hips. You need them to follow along. Now, this is actually something that's really, really easy to set up with Contour, and, we've done it before on stream, I think probably a couple of times. And what makes it so easy is the Contour deform field constraint. Because the deform field is what is deforming the mesh. It can push these things around too. This works really, really well. However, in the context of the componentized system, it does require us to think a little bit about where actually does that constraint reside. And because what you could do outside of the context of trying to do this in a componentized way, you would simply constrain them, and that's it, the end. It's no big deal, right? We don't want to do that because we want there to be components. Now, a possible approach to this, but one that I think would be the wrong approach, would be to have something where you bring in some components and you get most of your behavior that way, but then you end up as part of some process that you do to sort of finalize the rig or something, it goes and generates those constraints. I don't want to do that. And part of the reason why I don't want to do that is that it essentially, one of the really nice qualities of the componentized approach is the idea that stuff like that is not happening, right? And you can see that to be true everywhere else, right? I can go, and if I go and move this knee, it will readjust the whole rig to be what it would be, right? If I had an auto rig system and I had these guides, sorry, they're hard. You wouldn't really have these both things visible at once, right? And I had these guides, and I was setting up, it basically used them to generate the rig. You want the exact same behavior that you would have otherwise, but dependent wholly on the guides flowing through the graph. So it would be sort of a violation of that principle, right? And you'd lose some of the utility if you had to actually sort of manually build something and rebuild it. So I don't want to do that. Another approach would be to pass data of a different type through the barrier, through those inputs, right? Like you could conceivably, and this is not something I'm going to do because I think it would be a little complicated. Outside the context of Maya, I think maybe this would be the right thing to do. But you could conceivably have things that are things other than world space matrices. There's a deform field generated by this spline, right? You could have something that says, well, I actually pass an attribute through that is the deform field that they can be constrained to on the other side. In Maya, that's going to be that is not going to work right? Like, you're going to need to pass a lot of data. It's going to need to be some kind of array attribute. It's not simple and clean like these, like, world space matrices where you just go make a matrix and hook some stuff up to it. It would be a lot more complicated. And that's just sort of like a Maya implementation thing, right? If this were some other way of defining rigs, if this were control rig or something, right? And you could simply pass whatever data you needed around very easily, no matter what that data was, even if it was some more complex data structure, then I'd say that's probably the right thing to do. But we're not going to do it here. What we are going to do is to take advantage of sort of the rules of the components that I've set up, at least in this particular system. There's a lot of different ways that you could design a system of rig components. But the rules that I've decided on for this one are this. Any given component interior, so if we look not at the guides, but at, like any of these things, right? All the stuff that the actual leg controls do depends wholly on the inputs received through this inputs node. Now, the inputs node itself is just sort of like a convenient way of knowing that, right? Like, there's no actual rule that says they have to specifically be attributes on the inputs node, but they do have to be a specifically defined set of attributes, and you can never have any more or less, right? And so there's a rule like the component can communicate with other aspects of the rig only through inputs and outputs and never through anything else. So you can't, that is one reason why you can't just go constrain these things, right? And deal with the constraint. That would be, that would violate that rule. And the reason not to violate that rule, even though it seems convenient in this case to do so, is that you end up in a situation where the swappability of components goes away. And that's something that I think is pretty important to like what's good about the system, right? However, there's an easy way that we can get around this, which is, sure, the rule says the component must depend wholly on its inputs, and the inputs happen to be hooked up to guides that happen to be in the same place as the component, right? That is to say, they are referenced in with the same file. However, the system does not anywhere say that a particular input must be hooked up to a guide from the same component. You could have inputs coming from anywhere. You could have inputs coming from other components. You could have inputs coming from the guides of other components if you wanted to. It doesn't matter. Well, the thing that matters is that the component itself can only interact through a very defined interface. So what we can do is, well, we should, one thing I just realized I haven't actually done yet, and I'll do that real quick, is to make like make this locator visible. I guess for some reason it's not. So that you have your leg and you can move this around. We can then pass that data into the spine, through a new set of inputs we'll make for the spine, which will create some locators on the spine side that are constrained, and then it's going to pass its data through the spine's outputs over to the actual legs inputs. And that's actually fine to do in the context of this system. It does make things a little bit more complex, and it's not something I'd want to do for every system, right? Make them interrelated like that. But the important point about that is, sure, the guides are communicating with other components, but only through inputs and outputs. So we haven't actually broken any rules, right, in that case. And I think that's pretty much fine to do. And I think it's probably, of the various options for dealing with this, the simplest and cleanest and most sort of in keeping with the intent of doing these components. So let's start setting that up. Actually, the first thing I am going to do... I don't know if I actually made any changes, but it doesn't matter. The first thing I'm going to do is go make this thing, because apparently I didn't, for some reason. I don't really know. The hip overshoot guide should have had one of these thingies, and it doesn't. So I'm going to go make it have one of these thingies, which actually is maybe a thing worth showing, because that way you can see me do it, right? And actually doing it is again, this is something used to build the components. So it doesn't have any GUI, right? This is something that I do really have to just do through Python, but it's pretty simple, right? I've selected this thing. I'm going to say create node. The node I'm going to create, see, I was looking it up here, is contour guide shape. And then I'm going to tell its parent to be the current selection. And as you may or may not recall from previous streams, I've just set up a couple of convenience functions for me. S1 just means like the first item in the selection. And there you have it, right? Doesn't plug into anything yet. Well, actually, no, it does, because this overshoot guide already does plug into things. Oh, right, and I better also do this, because you're not supposed to do anything other than translate it around. And I will make it non-keyable, because you know, guides aren't things that you animate. And I'll give it the same. I will give it the same color. What color did I decide to give these? 1.1. Okay. Probably I should actually hook these up to something so they all change at once if I want to change it. But since it's actually fairly simple to do that, I haven't bothered. I mean, you could literally type it in for all of them at once if you wanted to. Yes. And I also need to make a connection shape. Made myself a little transform to just stick all those under. What is that? Contour guide connection shape. Now, in this case, we need to actually hook up the transforms, which I have actually written a script for, but I will do that by hand real quick because you might want to see how that works. I mean, it's really pretty simple, right? All I'm basically doing is, because I want that thing to have a particular... well, actually, before I do anything else, you can see the thing's like a big, thick cylinder right now. I'm going to go get the... okay, so where do we have? Which one is this? No, that's the new one. Yeah, that's the one. I want the same thickness. I had a little bit of rigging to sort of automatically define the thickness, and I want the same one for this. So I will do this one dot. I think it's radius. Is that the? Yeah, it is. So the first item in the selection, radius, inputs, whatever those may be. I don't even know what they are. It doesn't matter. User defined. No, not user defined. Sorry. Inputs plugs equals true, because I want to get the actual incoming connection. I realize I am using some ad hoc Python here, and I think for the components, I've sort of given up on trying to do some stuff completely without it, because when constructing these things, it is just very much more time consuming not to do so. But everything here is, you know, possible to do through the graph. You just have to go visually hunt for stuff, and it'd be a pain. The inputs plugs equals true, so that's whatever is controlling the first selection's radius, and then I'm just going to plug it into the second selection's radius. And it doesn't like that. List and attribute. Yes, that's because I'm doing this very silly thing and forgot that it returns a list. There we go. Now it's got the right thickness. Now it's got the right color. Now I wanna. Oh yeah, I gotta do the radius for these too. There we go. And I'm going to make this one actually stretch between those two. And to do that, I am going to do this really simple thing. I'm going to grab this one. I'm going to grab this one. Except I have both of those things visible right now, so it's kind of a pain. Wouldn't actually be true in real life. I'm going to get both of their world space matrices, plug them into some decomposed matrix nodes. There we go. See, I've been using Unreal a lot recently, and in Unreal, like, you know, duplicating a node by copy and paste is a very normal thing to do in, like, the Blueprint editor. And I keep forgetting that that's a very bad thing to do in Maya, and you absolutely shouldn't. And then we literally just take output translate, plug it into point 1. I'll put translate into 0.2. It didn't quite do that. Oh, because somehow that didn't go. I'll put translate into 0.2. There we go. Yes. That is what I wanted to see. All right. So that just made visible something that already existed, right? Now, let me go do the equivalent thing for the spine. So for the spine, I'm going to add 2 locators that are going to be constrained, but I'm also going to add some additional inputs. So let me start by adding a new input. I'm going to call this... what am I going to call it? I'm going to call it left leg overshoot. Now, it is worth noting that one of the nice things about this, it is completely agnostic as to what leg means in this context, right? Which is part of why it's componentized, right? It assumes that a leg that is hooked up to this spine, which is a good assumption, will need some overshoot. But not what kind of leg that is. If we had a quad leg, it wouldn't make any difference. Or a weird spider leg, or I don't know what, right? All it's assuming is that the character has 2 legs, and that those legs will need overshoot, and that's the only assumption involved at this point. So left leg overshoot, data type equals matrix. Yep, and then we do the same for right leg overshoot. And I'm going to hook up a couple of locators to that just to get them in some reasonable place so that it's evident what we're actually doing here. So like, I don't know, just like one over here, right? And one over there. Those aren't actually going to become guides, right? This data is going to be fed in by from the leg guides actually, but it is we just need to like position these things somewhere. And also Maya actually makes their data be none, right? Like if you have a matrix attribute and you've never actually put any matrix in there, it actually isn't the identity matrix. It is actually none, which I don't love. Sometimes you get weird consequences of that. All right. Going to take their world matrices. Once again, inputs are not visible because this is the Maya node editor. And that's how we do things in Maya. All right, so these are inputs. We're just going to ignore these actually, because they're just there to be able to set something, and maybe I'll just delete them now that I have. I'm not sure. But now we'll make the locators that are the actual things that we're going to constrain. So these will actually be going under. I think actually the best thing to do is to put them under character. Now remember about these spaces, and this had to do with space switching and stuff. But the character space. I mean, actually, come to think of it, I'm not sure that it actually matters. I think it can be in world. There's no actual need to put these locators under a hierarchy. And actually, this is one thing that often helps rigs to be, well, it both helps to sort of simplify them, and it often helps performance. And in this particular case, I doubt it matters very much. But when you add up a lot of things like this, it actually really can. Where the idea of sort of basically stuffing a bunch of stuff inside a hierarchy is because it's sort of like part of the spine, so it should go in the same hierarchy as the rest of the spine, is actually not relevant, right? Because the constraint will tell this thing exactly what its transform ought to be. It actually doesn't matter, right? the hierarchy does nothing except to prevent the parallel eval from scheduling it until its parent has already been evaluated. Like, that's the only thing that actually does. So we might as well not do that, right? There's no reason to. We're gonna call this left leg overshoot, and we're gonna make a right leg overshoot as well. And we'll go ahead and make the constraints, but we're actually going to change some of the information about those constraints shortly. This is actually a really cool thing that you can do with Contour. Create deform field constraint. Create deform field constraint. Now, just like, and you know, I mean, just to see it working, like it's now gonna, you know, move around with the spine as one would expect, right? Now, just as when we are performing, you know, like standard linear blend skinning, right, or anything similar, right? These things have, in order to be in some particular place, they have some actual matrix for that, right? And normally speaking, you don't actually define it; it just gets set because you've put this in some particular position. It figures out what the like, I guess you could say the bind matrix. Like, I'm not sure if that's quite the right term in this context. It's not a bind in the usual sense, but it's basically the same concept, right? Just like when you're binding to a conventional skeleton, it has to find a bind matrix because it is actually the difference between the bind matrix and the, or rather, in this case, the bind matrix relative to the bind spline, and then the actual matrix relative to the actual spline, or rather deform field, that produces the actual movement. So if we take a look at this, what we can do here is, here's our deform field constraint. Actually, it's been a bit since I did this, so let me, yes, initial world matrix. So we've got a bind deform field and a deform field. What's actually producing the constraint is essentially the difference between those things. But because this isn't a mesh, right, it doesn't have a whole bunch of points to essentially be following that difference, there's only really one thing. There's an initial world matrix. We can go change what that initial world matrix is. We can, for instance, bring in the inputs and say that, which one was this that we're doing here? Which one is this plugged into? Yeah, it's left leg overshoot. We can say that the left leg overshoot matrix that we're receiving here is actually what's going to set our initial world matrix. Now, we won't see much of a difference here, right? This is going to behave just as it always was. However, we can now move this thing around. And what we are essentially doing when we do that is resetting its initial matrix, right? Now it's going to behave in the right way for a matrix, a transform that's down there. Now, I will note one thing. I'll just note one thing here real quick. This sort of looks a little weird, and the reason is that the radius indicators here don't actually do the stuff that Contour does. Like, they don't follow Contour's mesh spread or anything. They're just there so you can see the radius. So you can see, like, the kind of, like, it's weird and looks like they slip around, but that's actually not a problem. Let's just turn them off because they're sort of distracting. And if you sort of imagine the way a mesh would work with Contour, like, that's exactly what it would do, what it's doing right there. That's exactly what it should do. So, let's do it for the other one too. Just put it back over there, I guess. This is actually a really nice technique. So here's actually something I'll just mention. And maybe I should do something like this at some point on the stream. It was actually really cool. Where I had a character with a long coat. And that character sometimes needed to, like, slip their sleeves up and down their arm in various ways, you know? And so the way that I was rigging the coat is I was actually using wraps, a wrap deformer. Because what I wanted was the ability to have a low-res cage for the coat. This was a case where it didn't make sense to just use Contour for the fabric, because I wanted to be able to basically have a bunch of points on the surface that I could sort of stretch things between, and essentially define the shape of the coat very precisely, including the sleeves, because the sleeves were these baggy sleeves. I had to do all kinds of stuff. Now, of course, what I did with the sleeves was I took all those points and I drove them with Contour. I drove them with deform field constraints. So one thing that I could do with this, to have the character, like, sliding their you know, the sleeve, like up and down their arm, was that I could take those points and I could give them two different possible bind positions for the deform field constraint, and a slider that essentially went between those two different possible positions. So that and what the thing that this really gets you is, if you have a sleeve and you have points that are relative to that sleeve, and you just translate one down like this, it's relative to something back here. So if you curve the arm with contour, like, it won't necessarily pick that up. Like, it'll do something kind of weird. You really want it to be as if it were bound down here. And sliding around essentially within the space, what that allows you to do is to slide around within the space of the deform field, so that it's always following the arm nicely, even when the character rolls their sleeve up. So that's very, very nice. And in fact, it's the exact same thing that would happen if you put a blend shape underneath contour, right? It's same basic concept. The difference being there are fewer points being rebound, because it's not a whole mesh. It's just a specific set of controls. So same basic concept, but doesn't have as many performance implications as doing blend shapes underneath a contour deformer. So let's go do the other one. Should be pretty simple. Let's grab the constraint. Let's grab the inputs. This one's the right leg. We just plug it. Wait, what? Did it automatically know which one to do? Oh, it did, actually, because that's probably the only matrix connection in the whole node. All right, so same thing. All right, I think we can delete these locators now. They're just for setting that data somewhere, right? It doesn't even matter where it is. And later, I'm going to come back and probably remove the locator shapes, because there's no need for them to actually be visible once we get this all hooked up. But I'm not going to do that just yet, because it will be helpful in the next bit. All right, let's go back to our body plan. So, as I was mentioning, we now have something where there's a spine, right? But the spine just has these two things, these two inputs, right, that have received matrix data from something. It's been set to something basically, but isn't nothing's controlling it right now. Nothing will happen if I move the top of the leg around. But that just means I need to make another connection there. So let me grab the spine inputs. And let me grab this guide. And this is going to be real simple. It's actually going to be the same thing that we've done inside all of these component files. Because the thing that I realize, actually, is that that is actually a distinction that seems like kind of silly, but it also almost kind of matters, is that there's actually a difference conceptually between the component and the file. The component is actually like literally the component. The guides are not part of the component. The file can include both a component and guides, but it's not actually the same thing, which is kind of why this works, actually. So let's, no, that's the wrong one. This is the right one. I'm going to plug this into, that's the left one. Left leg overshoot. We're going to plug the other one into right leg overshoot. All right. So it's not super visible because actually these things are kind of covering them up. But what's happening right now, or at least what's supposed to be happening, is I'm moving this thing around, and it's actually defining where those transforms are in the spine. And it's really worth noting here that there's no circularity happening here, right? You could be like, oh, well, the spine controls the legs, but now some aspect of the leg is controlling the spine. That's actually not the case, right? One of the leg guides, which have no relationship to the spine, the leg guides don't know anything about the spine, are passing some data into one of the spine's inputs. And then one of the spine's outputs, which actually we didn't go make the outputs. I'm going to go back and do that in a second. Is passing some information to the actual leg component. Because the guides and the component are not the same thing, this is actually forward. Like the graph of this, if you were to think about this as a graph, it's a forward graph. There's no actual, like, data is never flowing backwards here, which is part of the reason why this is an okay thing to do. I like to avoid actual circularity. I mean, and of course, like in a lot of cases, actual circularity in the Maya graph will like blow up on you, right? But there's also lots of cases in the Maya graph in which things are actually genuinely circular, like actually all constraints, at least by default, unless you deliberately break connections. And there are cases where it's kind of hard to avoid that, but I actually really dislike it. I think it's sort of like unclean, and it adds additional complexity. And as an example, the ephemeral system, despite allowing behavior that sure looks like it's circular, is actually not at all circular, right? In any given set of things that you are doing, in any given operation, everything's purely forward. It's just that it can be a completely different thing from moment to moment, which makes it look like it's circular.
I mean, the dependencies can be circular in the ephemeral system. It's just that there's an order in which you walk, and as soon as you hit a conflicting one, you're done and you don't include it, right?
Right. So I was thinking of it more as the graph. So in a sense, the ephemeral system has two graphs. Like there's the graph of dependencies, possible dependencies, right? And there's the graph you actually evaluate. And the possible one has connections in all kinds of different directions, and they're totally circular, but nothing ever evaluates based on that. We walk that to find the actual graph to evaluate. Let's see. So, right. We need an output. We need an output. We need it from spine. We need to add some additional outputs here. Right now we were only doing pelvis and chest, I think because we needed them for purposes of space switching. Now we need a couple of others. Right. What do we want to call this? Right, I mean, same thing. Like, left leg overshoot. Data type equals matrix. And the same with the right. And just like with the inputs, and I know I've probably mentioned this before, but I just feel like it's like an important aspect of this. The rules of the system itself, like the conceptually, do not like you don't actually have to pass everything through this node. It just really, really helps to keep things organized, right? Like, because you do have to have explicit inputs and outputs that can only ever be one thing. They could have multiple nodes or whatever, right? Like that's not an important thing, but it sure helps to keep them organized if you pass them through the one node. And there is actually a question about whether this will actually bottleneck something for parallel eval, because mostly we're not evaluating this stuff. I think it's probably fine, but like, you know, in a more complex system like the componentized system that I did for the TTF, the third floor, there is actually a published step that gets rid of the input and output nodes and like rehooks everything up to be direct so that it can't bottleneck parallel eval. But in this particular case, there's very little information being passed between components. It's almost always from guide to component, and the guides don't actually animate. So in most scenarios, I think this is probably fine, and I'm just going to leave it in place. So left leg overshoot, right leg overshoot. Yeah, let's hook them up. And that's, you know, again, it's as simple as just passing these world matrices around. One thing that I will say, and people have sort of criticized this, and I think they're not completely wrong too, is that one could construct this system without so many transform nodes. And in fact, there are reasons why maybe you would want to do that. Maybe you want to really, really rely heavily on matrix nodes. I mean, here I'm using a transform node, and I'm not even transforming anything, right? And yeah, I mean, honestly, I kind of agree that that's not great in many respects. But it is something where there's a balance here of trying to make something. I mean, this is always an issue, right? We're trying to, in many ways, break out of the way that Maya does things, and in some ways that's painful. And so sometimes we make compromises where if you were doing things in a system that was designed for that kind of recreation, then there'd be no reason to ever do this, right? But we're kind of not, and so I don't know. Sometimes I feel like it is worth compromising on some things to maintain the simplicity of interacting with it, you know? And your mileage really will vary with that. Like, I don't even think the people who criticize this are actually wrong. It's just that you gotta, you make your compromises where they happen, right? You know? So, now let's pass this information through. So here's what we're going to be doing. Hopefully this will work the first time. We'll see. One of the things you can do with a reference is you can override incoming connections, and that's exactly what we're going to do. We still want these in the reference to be connected to the inputs. Again, we're not changing anything after the input, only what goes into the input, right? But it's kind of okay to break that connection and change it to be something that we have in the overall body plan, you know, outside the input. So let's do it. Let's see. We need left leg guides, right? That's left leg guides. We don't need left leg guides. We need the left leg component. And one of the inputs that we have on our left leg component is hip overshoot. That's right. And that's what this is going to end up controlling. Let's grab our spine outputs. Honestly, I sometimes feel like a lot of my drive to make rigging simpler and comes from just getting lost in all of the crap. You know, like and that's exacerbated by things just being complicated in terms of how Maya interacts with things, right? And sort of Maya's assumptions about things. But it's also just generally true that rigging is complex. And one of the reasons I don't like that is because it turns my brain inside out sometimes, looking at all of the different things that I'm dealing with. Aha. Well, that did not work. It's very clear that that did not work. Now I have to figure out why it didn't work. Let me just follow this back. Left leg overshoot. Alright, that ended up in the wrong place. And why did that end up in the wrong place? Because it is, in fact, putting it exactly where that transform is, just the transform's in the wrong place. And now the question is, why did that happen? Here's the deform field constraint. Here's the deform field. Here's the contour spline and all of this stuff. Here's the spine inputs. Am I possibly putting a wrong thing in there? Left leg overshoot, so this should be flowing through pretty directly, and it's coming from here. Am I not giving it a world matrix? It's under all is transformed. That's a world matrix coming in here, right? Because if it wasn't world matrix, no, it's world matrix. If it wasn't world matrix, you would expect it to get all broken, right? Because you'd be getting some local matrix that wouldn't actually fit. As it is, here's the issue. This is being plugged into the deform field constraint. I wonder if the deform field constraint is actually somewhere in a hierarchy that it should not be in. That is all identity. Well, now we get to the part where we have issues and we need to solve them. Not actually my favorite part of this process, but it is a necessary part of rigging. So we saw this working in the case of the spine, like when we opened up the individual control. And so actually what I actually want to do is to go back to the spine control and watch what it does, right? As I move various aspects of it around, because this will probably tell me something. It'll build some intuition as to what could possibly be wrong here. That all looks correct. But what happens if we move... Oh, no, you can't move guides itself anyway. What happens if we move this around and also change some of this stuff? Yep, that is all working correctly. That is all doing exactly and precisely what you would expect it to do in this circumstance. I am thinking that when I hooked that up in the scene, I was sort of like, oh, I thought this worked. It actually didn't work. I thought that it worked because I couldn't see the actual thing, and I don't think it was ever actually in the right place. So let me... That probably means that the matrix data being passed into it, because we've seen this work with just like 2 random locators, right? Let's go back to the body plan, hook up some locators to it, and see what it does. Instead of these, because this is at least a specific thing that is doing a specific thing, right? And is, oh, that's interesting. It's about the same height off the ground, isn't it? That really does suggest that the, let me see what happens if I do this. I want to see some things. Oh, interesting. Huh. It is taking on additional transformation. We have some double transformation going on here. And that shouldn't be happening. But it actually makes sense that it is if that's actually the issue. Let's put this back to 0. Now, see, even that is actually incorrect. Is it influenced by these at all? It is not. Oh, it is influenced by that one. Which it very much should not be. Interesting. Well, now you get to watch me flail around while I figure this out. All right, a couple of things to try. Right, we know that's wrong, but what happens if we go put this back to 0? What does that change? Nothing much. Okay. I'm just like building, you know, it's this thing. You say this a lot too, or building intuition, right? I'm watching it behave wrong under a lot of different circumstances, which is going to help my brain like make sense of like where's the disconnect? Where is this wrong? Here we've got hip overshoot. Let's hope
logic
the pivot didn't get moved. Let me just check this for a second.
Yeah. As I always say, logic is for people who don't have intuition.
Right. Well, it's just that if you try to logic this through, it takes 10 million years, right? I mean, you've gone out of your way to try to teach me that when it comes to programming, right? Like, don't try to think it through. Go print some stuff and see what the information is. So I'm just gonna start messing around with some stuff. So if I make this connection directly, does that change anything? It does not. Just in case somehow, and this is very unlikely, having this in the middle had some sort of effect. Seems not almost guaranteed not to be the case, right? Here's the deform field constraint. Its actual transformation is irrelevant, right? It's just a constraint. It really shouldn't be a transform node in the first place. This thing, of course, has a transformation, but it's wrong. And this world thing has a transformation. So let me try something else. I'm going to try doing this, but I'm not going to pass it through. I'm going to just do it to a random locator. See what happens. And I'm going to take that random locator, which is over here somewhere, and I'm going to first pass this through with a decompose. I'm actually just going to look at translation because I think that's the only bit. Yeah, okay, that's what I thought. Just like, you know, check your assumptions. Now I'm going to go create a deform field constraint for it. Oh, I have a theory. I know what's going on here, actually. I bet I do. Anyway. I'm pretty sure, what am I looking at? I'm looking at the wrong bit here. I need to look at the spine component. So I can go get the joint socket and use it to bind. Where did I put my random locator? Oh, it's over here. That is, of course, the wrong constraint type of constraint. Here, make it a form field constraint. Now, isn't that interesting? Yeah. Yeah, I kind of thought that we were going to see that. So here's what's going on here. The deform field constraint was created in a context in which the spline was in a different place than it is now. And to verify that, here, let's go find the joint socket. Now, the joint socket, right? The joint socket is under a hierarchy, and that hierarchy is being moved around, right? And so there's something here that isn't being updated. Let me just see what that is. Or let me just think about this for a second, because it seems to me... Yeah, let's go take a look at what's going on in the spine itself. We had those things, and they're following along, and you can see that they are now, right? They are constrained. But I didn't have those locators feeding into it anymore. I'm now going to have them feed into it again. And I'm not even going to go through the whole inputs thing right at the moment, because this is just yeah, I should actually. I will. That will make things a little easier. So what I'm mainly trying to do is to figure out where's this additional transformation coming from, even though I think I have a pretty good idea now what it is. But I need to see it to be sure, right? Yeah. Yeah, look at that. That is not working properly. It's just oh geez, that was not a great plan. There we go. And we can see that the leg overshoot is being plugged into the initial world matrix. Now, the difference here, I'm actually not totally sure, but the issue here is that the initial world matrix isn't sufficient, right? Because the spline itself is also changing, but its bind spline is not. When we say that, and here's why this is happening, right? So what we are relative to when we rebind, right? The thing that we are relative to is not the actual current transformation of the spine. It's the bind spine. Bind spine, splines, it is the bind spline. So if I were to, for instance, this is actually kind of an important thing about Contour, which actually lets you do a bunch of cool stuff. Like, it's something that is very good, but then of course, you can be unaware of what's going on if you aren't paying attention, like I apparently wasn't. Here's our joint socket, right? This is actually one of the things we kind of went out of our way to do with Contour, was to make what's going on here at least somewhat comprehensible. If you like graph it, right, it's not all totally opaque. You can sort of see what's going on here. There's this Contour spline, and all of these things are feeding into... Actually, you know what? I'll graph back from the constraint, because I think that's going to make things a little clearer. You've got a deform field, and you've got another deform field, right? The Contour spline, which is being driven by your bones and everything. But then there's this bind spline, right? So what you actually have here is two different Contour deform fields. And the difference between those deform fields are what actually produces deformation, or in the case of the constraint, transformation. So here's what I wasn't figuring on when I went to set this up, right? Because I've done this before in other contexts. But when I set up that system with the sleeve, the the spline had already been positioned. It wasn't. It didn't need to be rebound, right? And here's how you can see. Well, actually, let me just double check on this and make sure that I'm right. Pretty sure I'm right though. What happens here if we enter rebind mode? Notice how these things are jumping around here, right? Now, what this should do, entering rebind mode, though, is that it should have reset this stuff. And you can see that the two things are, I believe, right on top of each other when we're no longer in bind mode. So the, here's the locator. Where's the other, yeah, where did I put it? Put it in world. Yeah, here's this. Right, it's right on top of it. So it is the difference, the fact that we're applying this bind information to it, that's actually doing this. If I leave rebind mode, though, it does not seem actually to have rebound this, possibly because a deformer wasn't attached. That may actually be something we should address. However, let me just real quick see if the API will do it instead. Pretty sure I can do that from the... because I can just, like, explicitly tell it what to rebind with the API. Let's see. I think that would probably be about joint chains. Or actually, no, I'm sorry. It's about rebinding and rebinding. Let's see. Reset bind. That is the one I want to use. And I'm pretty sure we can just pass it a joint socket. Indeed, we can. Let's just back this up so we can see what happens here. What do you know? Let's just verify this is doing what I thought it should. Indeed, it is. So that's actually, you know, I probably should have anticipated that, right? Like, that's a little silly of me not to have taken that into account. It is a solvable problem. What we essentially have to do is to say that while these things are being positioned, and we didn't have to care about this before, right? Because we weren't relying on any of Contour's bind behavior for anything about the components was doing. But in this case, we actually do have to reset the bind on that in order to make sure that everything binds correctly with this world position. It makes total sense that this is what happened. I just wasn't thinking about it, right? So let's see. I'm just thinking about like the best way to ensure that happens. And what I think I'm going to do just for now, because this is actually so in terms of the feature we intend to release, this is actually, you know, extraordinarily simple to solve, right? Because what we actually are presenting to the user is a case in which we're sort of entering a mode, right? And when I built these things with these pieces, like, I wasn't really paying any attention to the mode as such. 1 second, let me get my YouTube like thing back. Yeah, there we go. In case I can see if anybody's saying anything. Nobody is, but I just wanted to check.
Yeah, I've been keeping an eye on it.
You've been keeping an eye on it. Okay, good.
Yeah. We did have a comment, but I wasn't sure that it did not seem to be a question. So.
I admit I am a little puzzled by that comment, actually. I may be missing some context for that.
You know, I didn't see exactly when it happened. There might have been something alarming going on the screen at that point. Okay.
But anyway, well, I mean, I'm sure there was. There have been many alarming things. This has been a very exciting stream.
Thrills and chills.
I know. So anyway, in the context of what we actually want to do, this is actually really simple to solve, because and in fact, in the context of what we ultimately are attempting to do, I think it may just work by default. No, we might have to. The fact that that didn't rebind when we entered rebind mode, that's probably a bug actually, on our part, because as you can see, when we explicitly rebound, everything worked perfectly, exactly as you'd expect. But I guess rebind mode maybe didn't notice that it needed to, possibly because there wasn't any deformation going on. So we should add that to our list of things to investigate. But regardless, this would also be very easy to do, in terms of if you're sort of entering a mode. So like the idea, the eventual way that the user would use this, which sort of in some ways mimics the feel of like how auto riggers tend to behave, right? The idea would be like you go into this component, like right. So you hide. Well, all right. Let me actually go back to just delete this and go back to the body plan so I can show you what I mean, right? So the idea here is each of these things may be hidden, right? So in a sense, there's sort of a mode where you're manipulating these things, because if they're both visible at the same time, it's very confusing looking. So we want to give the user the ability to just flip back and forth. And at any time, and also we automatically enter rebind mode when you flip to take a look at this. So it's just like, oh, you can flip over here, you go and you reposition some stuff, you change your thing, you just flip back, and then you just keep going. It's a workflow a bit similar to what something like TSM3 did, but because because of its components, there's no build, right? We don't have to like save a bunch of data and rebuild anything. And as a result, it's instantaneous, right? There's no need, like it's not this thing where it's like, oh, you go rebuild. But number two, and I think this is actually one of the really critical things, it preserves any changes you've made. Now, we don't really think that people ought to be like, I mean, unless you want to go make your own components and stuff, but we don't really think people should be reaching into the components and changing stuff. But if you want to, and this was actually a really key thing that we've made heavy use of with our rigs at TTF, which is you can go do other stuff in the rig, right? Because like there's stuff that could be downstream from this, right? You've got a character, but it's not just all bound to the same stuff. Maybe your character has armor pieces, it's got secondary controls, it's got like clothing controls, it's got like all kinds of stuff. And one of the problems that we kind of we had to avoid dealing with it for the setup machine, for instance, is it's all very well if you want to rebuild your rig with an auto rigger if you haven't changed anything manually. And you can in theory just rebuild the thing. But if you have, that becomes incredibly difficult to manage. Like, not maybe impossible. Like, in theory, I mean, we kind of had discussions about this as I can recall. In theory, you could, like, kind of scrape all the connections, as it were, and just sort of, like, pull them all out and put them all back and, like, kind of get everything working. But like, to actually make it work consistently with any of the things that the users could have done, this would have been a like, really prohibitively difficult, I think. Whereas here, it all just sort of, it's fine, right? Nothing ever gets rebuilt. So it's perfectly fine to have, like, whatever other stuff you built downstream from the components in the rig. I mean, you could have all kinds of other controls that you added to your rig. You could have all kinds of other deformation. It's totally up to you. You could even, and this isn't something that I particularly recommend because it is, it does, like it's not as componentized as I would like, but there's certainly nothing stopping you from doing it. You could go and parent some stuff directly to these controls, and it would still work, right? Because nothing about these controls is actually, ever gets recreated when you're changing the character's proportions. So this is all super nice, but because you're flipping back and forth between looking at it one way and looking at it the other way, adding a little thing that's like, oh, and by the way, just like rebind that thing when you do, would be trivial, right? Very simple for us to do.
That's nice, because the thing about what you're talking about with, say, an auto rigger, with the setup machine, having worked on TSMG and TSM3, it's the kind of thing where you can make that work in a lot of cases, with a lot of work, but making it work in all cases, given the way that Maya works and sort of the arbitrariness of stuff, is a pretty difficult challenge, right? And one of the things that I'm not crazy about is stuff that works some of the time.
Yeah.
Right. And you don't really know, it's like, it's it's not a good characteristic of a system that it works like 80% of the time,
Right.
because you don't know. You're like, well, I'll try it, maybe it'll work, maybe it won't. It's confusing. Anyway.
Yeah, it is totally. Well, I mean, and I remember us talking about that. Like, I remember us trying to do that for TSM3, or I don't think we ever seriously tried to do it. I remember us discussing the possibility of doing it, and then being like, yeah, this would never come out if we tried to do that, right? Like, we were like, yeah, this isn't happening, right?
Right. We could have gotten it probably so that it worked 80-85% of the time, but it's really, really annoying when you've been expecting it to work and you hit that 15% of the time, and like that scotches your plans, and it makes it kind of not worth doing. If you ask me.
Exactly. It's just sort of like there's so many possible corner cases. The nice thing about this is, assuming you don't break the actual components themselves, because of course the user could conceivably break their connections to the inputs or like all kinds of stuff, and if you go and do that, all bets are off. Like, obviously you just broke it, right? But anything you want to add, no matter what it is, will keep working. And so that's very, very nice. But my point basically was, this issue that we discovered with the rebinding, it's trivial for us to solve this in the actual use case. What I'm thinking about is, for purposes of demonstration right now, what's the best thing for me to do? And I think the thing to do is, again, this is for demonstration, right? Like, and in the real situation, it's trivial to deal with this. So it's probably fine. I'm just going to have a little line of code that I'm going to run that's going to be like, oh, by the way, rebind that thing, right? And I think that'll actually be fine for demonstration purposes, you know? It is a little unfortunate. It's something I really should have thought of before I started to do this, because now that I'm thinking about it, I'm like, yeah, this was an obvious issue with this approach. Even though it's not really like a serious issue. But, you know, but that's how this stuff works, right? You know, you always like, you know, no plan ever survives contact with the enemy, and that's, you know, part of the experience of rigging, and part of the experience of designing rigging systems. Because I will actually tell you, this is part of why I have spent so much time trying to make this better. I mean, also the stuff I was talking about before, but like, I love actually on some level designing rigging systems. I hate rigging, right? People are like, how could you possibly hate rigging? It's sort of what you're known for. Yes, but I don't actually like the experience of doing it, especially when it's repetitive. But I really like the experience of figuring out how it ought to work. And part of the purpose of things like this is to be able to figure out how it ought to work once, right? I mean, and that's supposed to be the purpose of an auto rigger too, except that an auto rigger tends not to actually fully fulfill that function, right? It sort of does, but then you have something that's outside its context, and it, you know, and that all breaks down. So anyway, sorry, that was a bit of another rant. But you know, now I know what's going on, and it makes sense that that's what's going on, and you know, it's not the end of the world. This is actually correct. It's just that if I actually want this to work the way you would expect, I gotta do this, and now it's fine, right? And it's all about regenerating the bind spline. It's just, you know, the bind spline is supposed to just hang out there and be one thing. That's how it works. That's how all sort of bind data kind of works. It's just that in this case, you've got to always reset it. Let's see. What do we have here? Oh, I should also rename these. Of course, that's trivial to do, again, because these are all in component files. I can go change the names on everything. Everything will just keep working, and anything we stamp out with the system will now have the new names, you know? God, I'm so... The old way of doing things was so painful, you know? Let's see. Right. I'm just reminding myself like what I was doing when I was so rudely interrupted by things not working the way I expected them to. That's right. I'm going to take the spine outputs and plug them into the leg input. Except I randomly opened the world matrix, even though I don't actually care about the spine's world matrix, right? Certainly not of the spine component, which is actually not the same thing as the input. I'm sorry, I must be tired today. And we don't even care about the inputs, we care about his outputs. We do care about the leg inputs. And in this case, the right leg, because we haven't hooked that one up yet. There it is. This one's a hip overshoot. And in this case, you can see it didn't jump. And the reason for that is that we already went and reset the bind. And this should all flow through correctly. I can go reposition the thing here. It's so nice, right? I can go reposition that thing. Whoops, the wrong axis. And it is behaving correctly. Not totally correctly. Oh, I see what's going on here. Yeah. That's a thing I gotta adjust in the leg. So, yeah, that was silly. Here's what's going on there, right? Recall that when I set up, and in many cases this is true, when I set up the transforms like up and down the leg, I made an assumption about those transforms. I made a rule, right? Something that all the inputs received by this component are expected to follow, which is that this chain has to sort of be a forward chain. It's got to go down the chain. And it's not allowed to deviate from that. Now, which is perfectly fine, except for the part where these controls, of course, are deviating from that, right? You know, nothing about these transforms that we set in the spine have anything about pointing at the next control in the leg, nor should they, right? The spine's not supposed to know or understand or need to understand anything about that. So that's all correct. However, as a result, we're getting some real weird behavior. Like, I can't just like go fix it, but that should be a thing that shouldn't be too hard to fix. I'll probably fix it in a second. I just want to see it behaving weirdly again for a minute. No, I know what to do about that. Yeah, okay. That's actually going to be pretty easy to fix. It's just sort of obnoxious. Actually, and actually that's going to be a useful illustration of one of the other kind of useful qualities of Contour. One of the things about Contour is that it's sort of been developed, and you know, looking back on it, you know, we took a particular direction with the development that if we were to start it all over again, we'd probably do some things differently. I mean, that's literally true of every project you can possibly imagine, right? One of the things we did was that we sort of half assumed that a lot of the time you were going to have these contour joints and bones, and they were going to be in this explicit hierarchy, right? The contour hierarchy. We were like, but we were then like, well, but meaning you have to be in that sort of produces this sort of unfortunate effect, right? It cuts you off from some things that would be really useful. So then we were like, okay, it's not a rule, right? You are allowed to reparent joints and stuff. But not all of, you know, there are specific tools that we're doing that are still going to make the assumption that you don't, like IK, right? That kind of needs this hierarchy of things to be driving, right? So we're going to assume, and especially with the way that the contour bones work with like override rotation, certain things are gonna want you to behave that way. But other aspects of the system are going to be okay with just sort of things being reparented willy-nilly. And I kind of wish, I mean, I think that was a perfectly good set of assumptions to make. The only thing I kind of wish is that I wish when we'd initially made those assumptions, it became a little more clear to the user what the difference was between those things, right? And if we'd known exactly, I mean, this is always how all projects go, right? If we'd known exactly what we were trying to create when we started creating it, I think it would have been a little easier to provide that clarity, right? I think it should still probably work the same way, actually, but, you know. But let's take a look. So here's the issue we have here, right? So this you know, this is a case where we actually have to break, I think, and it's appropriate to break from our rule that like these inputs always go forward down a chain. Because in this case, you really kind of do want to have the spine be able to just like move it around wherever, and Contour handles that perfectly well. So here's how we're going to arrange for that. It's going to be pretty simple, actually. This control here, like well, I really do have to go back and name all these things. I don't know why I didn't do that. Well, it's because I'm lazy, that's why. Contour joint 8, right? it is currently in a hierarchy coming down from the joint socket. We're going to say, no, it's not. We're going to take it out of that hierarchy, just put it under the anchor, and call this, well, I mean, ultimately this won't be called contour joint 8, obviously. So we're going to call this something like hip buffer. Probably this will end up being called hip control, right? So, you know, I'm going to go back and fix all that. Now, this hip buffer, of course, is not currently following the, the guides. But we can hook it up to the inputs just like the other one was. In fact, in many ways, it's actually much simpler. I'm not even going to use the code, right? Because this thing, no longer part of the hierarchy, no longer needs to care what's going on with this bone and joint, right? All it needs is the direct world matrix of the, of the hip input. So I'm going to do that, and this is going to be real simple. It doesn't even need to be in any particular space or anything, because the whole thing with the anchor handles the question of what space things are in automatically, right? It sort of counters any double transformation that you would get. Let's see. Yeah, I mean, I literally just need a decompose node. I really wish I could be using offset parent matrix right now, but I can't be. Right. Hip. No, not hip overshoot. Hip. What am I thinking? I'm thinking that I've had a long day is what I'm thinking. Translate. Scale. Rotate. Shear. Remember that shear is actually important and you got to do it. It's actually not if you intend to never, ever, ever, ever non-uniform scale anything. But if you think that that's even a slight possibility, which I certainly do, connect shear. Actually, this should be all that's necessary, right? Let's see this working. Yep. That is all working perfectly well. All right, let's go back to where we were. That's one of the reasons why I think having these inputs that are just this list of attributes on a node, it just makes it clear and discoverable, right? If you're going to do something in a somewhat, I don't know quite what the right word would be. Haphazard is perhaps not the right word, but without defining, with a few, here's a good way of putting it. There are a few simple rules for this system. There's a handful of rules, right? There aren't a lot of rules. And if you're going to do stuff where there aren't a lot of rules, it's often helpful just to make the thing to do just as explicit and obvious and visually clear as possible, right? And so that's kind of why I like these nodes, even though they're not a necessary part of a system like this. So, what do we have here? Why, we have things working properly. That's what I wanted to see. All right. One more thing we have to do before we can fit it to an actual character. And I'm sorry to say, and this is not a huge surprise, this is how this has been going this past few times. We're probably not going to get to the part where we actually bind a full character today, right? We're probably just going to do this next bit because it's already getting to be like 6:18, which is mirroring. Now, mirroring is going to be a pain. One of the really nice things about doing like negatively scaled space mirroring, I guess you could say, right? Oh, let me just check on something real quick. Yeah, one moment. Just got to get back to something about my job. Like the actual, let's see. Just gotta respond about that. Okay. So, where was I? Oh yeah, let's get rid of this locator. That was just there to like test a thing. Right. We've got to figure out mirroring. So unfortunately, mirroring is often, it's often kind of a pain, right? When you're doing this kind of sort of, I guess you'd call it like, chain inversion. Like I'm not sure if there's really like a really well-defined term for it, but when you are mirroring matrices, it's ridiculously simple, right? You literally are like, you put the matrix in a in just like it's you actually literally just multiply the matrix by an identity matrix that's been flipped, like literally had one of its axes like inverted. It's like the simplest thing possible. So this is not the simplest thing possible, and I always get it wrong a couple times, right? Because of the nature of basically turning these things around in this way, and the fact that you have to maintain, I guess, what you might call the tangency of, right? I mean, like either something's pointing down x or it's pointing down negative x usually. But you also have to make sure that z points in the right direction. But you're doing all of this. This is why Euler angles are evil, by the way. We maybe could do a vector-based version of this too. I don't know. But this is another reason why Euler angles are evil, right? Actually inverting a vector is pretty simple conceptually. Trying to figure out what the appropriate Euler angle transformations are here is incredibly painful. There is kind of a rule for it, though. And maybe that rule will work here. And the rule is often like, you invert one of your transform, like you've got XYZ for both transform and rotation, right? So you invert one of those, in this case X, for transform, and you invert the other two for rotation. And this does not, depending on what spaces are in between. So that basically will always work in world space, right? But it definitely doesn't always work in every space. It really depends on the context. Let's see if it works out here, though. It may. Let me just write a little thing that does that, because obviously I'm not going to manually arrange this. Like again, I've sort of given up to some degree. I've been sort of forced to give up the idea that I was going to try to avoid too much ad hoc Python, because it's too hard to do things otherwise. But hopefully, and people can certainly let me know how they feel about this, hopefully it's not too painful, like hopefully it's at least the concept of what I'm doing is clear, even to people who don't really have any Python experience. Right, so actually I'm going to write a little function for this. I'm going to say I'm going to mirror the guide, and I'm going to say it's going to have source guide, target guide, like that. And I'm going to say, this is going to be a pretty simple function, right? I'm going to say target guide dot translate dot set source guide dot translate dot get times. I'm going to assume that I'm inverting. Well, I know I'm inverting x. And then I'm just going to do the same thing with rotation. And then we're going to find out what happens. Copy and paste is what I'm going to do. I'm kind of used to typing with those auto completion, and then I often don't bother to copy and paste because you can type it so fast, but that's not going to be true in the Maya script editor. I really need to check out, what was it? Charcoal? I'm trying to remember what it's called, like the nicer Maya script editor. I keep meaning to do that. Anyway, here's our mirror guide function. Yeah, I also can't type. And I'm going to give it the first item in the selection and the second item in the selection. So let's see what happens when I do that with these two guides. I mean, actually, I'm pretty convinced that this will be fine. Let's just remember we've got, in this case, we know where negative x is. We've also got y down and z back. As opposed to, in this case, positive x, y up, z across. So it's like all the axes have been mirrored across. Oh right, I did this already. All right, let's do it.
And Chris Fram is pointing out that charcoal is great. So I guess we really both need to try it, because certainly the Maya script editor is sometimes a source of frustration.
So this I think seemed to work. That all looks correct. Now here, I might actually have to do something kind of obnoxious, because this is going to be like, no, you can't do that. I bet it's going to error. Watch it error. Yeah, it's like, a child of the attribute shoulder guide rotate is locked or connected and cannot be modified. And indeed it cannot and should not be, because it is actually, like, the rotation for that is being figured out by an aim constraint. We shouldn't be messing with it anyway. I would think of a more elegant approach to this, but I am not going to do it for this little bit of ad hoc code. I'm going to do something real bad. Alright, I'm not going to be quite this evil. That's slightly less evil, right? It's still basically evil. If anyone wants to know why that's evil, what I just did there is going to swallow every single error that could possibly be thrown. Meaning, it could quite likely hide from me other possible issues. I would never ever do this in, like, actual code that wasn't just something I was typing into the script editor. So, sometimes you'll be able to do, oh, this still won't... Right, there are still some cases where this won't work, probably, but where I've I might have to do this attribute by attribute, which is kind of obnoxious. But let's see how this works anyway, as it is now.
One thing that I will sometimes do if I'm doing some ad hoc programming and I want to swallow all exceptions is at the very least, like, print something if one of them happens, right?
Right, that's actually probably the right thing to do here.
Just so you know.
Yeah, I'm going to hide the components. The components actually don't matter right now. Okay, sorry, I got to check on something real quick. All right, that just doesn't need much of a response. A thumbs up will do. And then I have some stuff to deal with when I'm done with this. All right, this is also all going to work, I think. And here's where it's going to break down. Wait. Oh, right. So it didn't break. It's not, so this is why you don't do this, right? Because here's what just happened. It didn't actually do anything, right? Let me just verify that, but I'm pretty positive it did not, in fact, do anything. Indeed. But it also didn't tell me that anything went wrong, because I just swallowed everything, which is really not what you're supposed to be doing. But actually, I expected this to happen. The problem here is now it can't set translate X, because those other things have been I actually kind of wonder. I should look this up, actually. I wonder if there's actually a something you can give to set that's just like, will set anything you can set. You know what? I'm going to look that up for a second. I should really know that. But I'm just going to...
Yeah, I don't think I know the answer to that either.
Yeah,
actually.
like there should be, which doesn't mean that there is. But also, I've been doing this long enough that I should know. But I actually am not totally certain if there is or isn't.
If there is, it's the kind of thing I'm pretty sure I've used it at some point.
Yeah,
if it does exist, because that's too useful not to have. But
no, there isn't.
Have a recollection of this. But yeah, that's actually the more likely scenario, I think.
Yeah, there isn't. That's unfortunate. It also, because this is how Mel works, right? And a lot of that stuff gets carried over to Python. It's got all this stuff where, like, set_attr does all of this functionality other than just setting attrs. And to be clear, like, when Python, when PyMel has a set, what it is actually doing is this is just actually calling set_attr, I'm pretty sure. But the unfortunate thing here is that set_attr does have all of this functionality that really doesn't belong in something called set_attr, but does not have the functionality to say, like, well, set this only if you can, which means you got to do it yourself, which I've done like a million times. I just didn't wanna. You know what I'm going to do, because I'm ridiculously lazy? I'm just going to treat those ones differently. This is not a thing that's, this is a thing I'm doing in the script editor. It is not a thing that has to, like, go into some actual, an actual module or something. And this one, of course, is ridiculously difficult. I'm sorry, what am I saying? It's ridiculously easy. I think the order I did this in here was like I did the source first, so let's at least keep the order consistent. second item dot translate x. I'm going to use the, because I feel like it. Oh no, sorry. Set. Ah, right, obviously. Times -1. Since it is the opposite. The equivalent of like what we've done over here. Yeah, all right, that's working. I mean, I think we may have made something. I'm a little unsure here. I'm gonna give this a try, but I think we've pretty much made something that's just gonna do the trick, right? Not in that case. I'm gonna come back to that for a second, because here's where we get into trouble with Did that actually work? With things being in rotated spaces. No, it absolutely did not work, and that's why it's a rotated space problem, right? What it should actually do is use world matrices for this. Actually, I really shouldn't be doing this stuff of screwing around with like, you know, this is going to be so much easier, right? If I just do this with matrices. The only thing that's obnoxious about it is the need to make sure that you invert the matrix in exactly the right way. Right, and that's kind of why I start out by doing this. But this is too ugly and obnoxious, actually. I'm just going to do it with matrices. Unfortunately, I'm not going to do it with matrices today, because it is 6:30, and our time is done, and we would have gotten on to starting to put this in a character, but then we encountered another issue, which I think was worthwhile, actually, because it elucidated some things about, well, how Contour, but not just Contour, how all deformation works, actually. And some other stuff that just, like, I don't know, it was sort of a useful thing to go over. However, the unfortunate thing is, we didn't actually start deforming a character this time, but I'm pretty confident that we can do so next time, because really all that's left at this point is just the mirroring, which isn't actually difficult, right? It's just, you know, kind of obnoxious. So we will be doing that next Tuesday, at this same Bat channel, right? Like and subscribe and tell all your friends, to come watch Notional Pipe streams, and eventually, I actually real time for really real this time. Like, I promise, we will actually be rigging an actual character with this.
Okay. Well, thank you very much, Raph, and thank you everyone for stopping by, and we'll see you next time.
Yep.